Welcome to today's session in physics. Today we are discussing some problems from the topic circular motion of the vehicles on the leveled road. Coming to the first question, a bend in a leveled road has a radius of 100 meters. Find the maximum speed which a car turning this bend may have without skidding if the coefficient of friction between the tires and the road is 0.8. So here in the question it is asked to find the maximum safe speed with which the vehicle can negotiate the curve without skidding. So for that we know the required centripetal force is provided by the force of static friction, and the expression for maximum safe speed is root mu rg. Substituting for mu r and g, we have V max is equal to 28 meter per second. Now coming to next question. A car of mass 1500 kilogram is moving with a speed of 12.5 meter per second on a circular path of radius 20 meter on a level road. What should be the frictional force between the car and the road so that the car does not slip? What should be the value of coefficient of friction to attain this force? So here the car, its mass is 1500 kilogram and its speed is 12.5 meter per second, and the radius of circular path is 20 meter, and we are asked to find the frictional force between the car and the road so that the car does not slip. So this frictional force should be at least equal to the required centripetal force. That is the condition here. So that's how we can find that frictional force. So finding the frictional force, we have that is the required centripetal force, that is mv square by r, that is equal to 1500 into 12.5 into 12.5 by 20. So we have 1.172 into 10 raised to 4 Newton. So key concept you should keep in mind, the frictional force is providing the required centripetal force. Now equating that force to mu r or mu n, where n or r is the normal reaction, we have the coefficient of friction as the force by mg, that is 1.172 into 10 raised to 4 by 1500 into 9.8. We'll get it to be 0.8. Now coming to next question. Calculate the angle through which a cyclist bends from the vertical when he crosses a circular path of 34.3 meter in circumference in route 22 seconds. Take g is equal to 9.8 meter per second square. To find the radius of the circular path, we can use the expression for circumference, that is circumference equal to 2 pi r. So radius r is equal to circumference by 2 pi, that is 34.3 into 7 by 2 into 22, where we have substituted for pi as 22 by 7. And the velocity of the object or the vehicle is given by length of the path by time taken. That means length of the path travelled in one complete circle. So we have 34.3 divided by the time, it is root 22. Now knowing V and R, we can calculate tan theta, that is V square by Rg. So substituting for V and R, we will get tan theta to be 1. So if tan theta is 1, theta is 45 degree. That means the cyclist has to bend through an angle 45 degree from the vertical. Now next question. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing speed and without bending towards the center of circular path. The coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip while taking the turn? Here the cyclist is having a speed 18 km per hour and the radius is given. Coefficient of static friction also is given. In this question, we are asked to find the maximum safe speed. The maximum safe speed is given by the expression root mu rg. Mu is given, r also is given. So substituting the values of mu and r, we will get Vmax to be 1.715 meter per second. And it's given that the vehicle is having a speed of 18 km per hour. Converting 18 km per hour to meter per second, will have the actual speed of the vehicle as 5 meter per second. So we can see that the actual speed is greater than the maximum safe speed. So the cyclist will surely slip while taking the turn. Only this much for today. Thank you.